In solving combination circuit problems, we have to use series elements and also parallel elements. Here's a brief review slide. Recall that for series circuits, the equivalent resistance can be found by summing the resistors. For parallel circuits, we have to use the 1/over relation. Similarly, in this lesson, as in others, I use the trick of coloring wires with electric pressures, with the positive terminal of the battery touching the highest pressure wire and the negative terminal of the battery touching the lowest pressure wire, which I always give a value of 0 volts. Again, with all circuit Sudoku problems, there's no right place to start. Since Ohm's law must be satisfied for any row in this table, we can quickly calculate that I times R is equal to 6.20 volts. Now, we're given all of the resistor values, so we should be able to figure out the equivalent resistance, which is the resistance perceived by the battery. So if we look at resistors 2 and 3, they are in parallel. If we use the 1/over rule with those two, we get a value of 2.14 ohms. In other words, if we were to tear out that portion of the circuit and put a single resistor in their place, such that the battery wouldn't know any different, we would put a 2.14 ohm resistor. This portion of the circuit is a little bit different from anything we've seen before. We can see that resistors 5 and 6 are in series, but that those two are in parallel with resistor 4. So first, let's find the equivalent resistance of just resistors 5 and 6. Since those are in series, we can add those up. 2.5 plus 6.5 is equal to 9. In other words, we have a 9 ohm resistor on the right and a 4.5 ohm resistor, resistor 4, on the left. Those are in parallel. So 1/over 4.5 plus 1/over 9, add it up, and take the reciprocal, it comes out to be 3 ohms. So, the resistance that is perceived by the battery is resistor 1, which is 3.5 ohms, plus 2.14 ohms, plus 3 ohms. This series of resistors gives the battery the impression that there's only one resistor and it's 8.64 ohms. We can now find the current going through the battery to be 2.89 amps. 2.89 arrow tails going through the battery. Well, there must then be 2.89 amps going through resistor 1, because any current that goes through the battery must also go through resistor 1. We can then find the pressure difference, or the color difference, across resistor 1 to be 10.12 volts. So now, let's color code these wires with voltages. We have a 25 volt battery, so lowest pressure, the color of that set of wires, is 0 volts, and this wire right here has an electric pressure of 25 volts. Well, the pressure difference across resistor 1 is 10.12. It's 10.12 volts different from one side of resistor 1 to the other, which means that the color of the upper left portion of the circuit, or the electric pressure of the upper left portion, must be 10.12 less than 25, which is 14.88. We're told that the pressure difference across resistor 3 is 6.20 volts, which means that the color of the upper right portion of the circuit must be 8.68 volts. 14.88 on one side and 8.68 on the other side. So the pressure difference across resistor 2 is also 6.20, which means we can find the current going through resistor 2. And notice that the current of 2.89 amps split going through resistors 2 and 3, and you can see that the sum is very nearly 2.89 amps. We now can see that with resistor 4, the color, or the electric pressure, at the bottom of resistor 4 is 0 volts, and the color, or the pressure, above resistor 4 is 8.68 volts. So the pressure difference across resistor 4 is 8.68 volts, which means that the current going through resistor 4 by Ohm's law can be found to be 1.93 amps. You can think of 2.89 amps going through the battery, 2.89 amps going through resistor 1. Then those 2.89 amps split going through resistors 2 and 3, but then right here they come back together. So if I were to put an ammeter right where my laser pointer is right now, it would read 2.89 amps. Those 2.89 amps then split right here. 1.93 go this way, which means the rest must go through resistor 5 and also through resistor 6. We can then calculate the pressure difference across resistor 5 and the pressure difference across resistor 6. If we wanted to color code that wire, we could find it to be, according to what we have, 2.40 volts less than 8.68, which is about 6.28. If we take the product, I times R, we would get, by Ohm's law, a pressure difference of 6.24, which is very nearly 6.28. A little bit of rounding error is nothing to be worried about.